Hi, this is Nick Kalyani, co-founder of Decentology. In this video, I'm going to tell you about the DappStarter architecture. When you visit the DappStarter website, you're going to see a user interface that looks a little bit like this. You first select a blockchain, then the blockchain language, a JavaScript framework, and finally, one or more modules that determine what your output Dapp is going to contain. Once you've made those choices, DappStarter will generate a new GitHub repository for you with the full stack, open source, MIT licensed source code for your application. Once you clone that to your desktop, DappStarter has all the orchestration and all the scripting necessary to run an emulator, generate test accounts, and a whole lot more, so that you end up with a user interface and a working environment that looks a little like this. Now, in other videos, you're going to see how this actually is built. But in this particular video, I'm going to take you behind the scenes and tell you about how DappStarter actually does this magic. So let's start with a broad overview of the DappStarter architecture. So we start off with number one, which is the web application that is the starting point. So there, as I mentioned, you choose a blockchain, smart contract language, and feature modules. Now what happens when you made that choice is behind the scenes, we have an intelligent agent that we call hypergrep. And what it does is it intelligently generates the code and figures out the dependencies that are needed, much like you would expect in, for example, the JavaScript NPM or Yarn packages to do. But it's a little more sophisticated because it has to take into account not just a single language, but multiple languages and multiple types of dependencies. Once this is done, hypergrep essentially is enumerating the manifest that is generated from the website, and it's figuring out, okay, which blockchain is needed, what is the language that's needed, what are the feature modules that are needed, and it's packaging all of that up into a single GitHub repository. And once that GitHub repository is created, you're given access to it, and from there you can clone it. Now within that repository, there are four primary elements. There's a smart contract, there's client application, unit tests, and server API. And we're going to go over those in just a moment. So within the DappStarter workspace, now this is the developer environment you get when you actually run DappStarter on your desktop. You have three primary areas, or groupings, if you will. We have the first one called Dap Lib. We think this is sort of the nerve center of DappStarter, and it is designed to be a standalone library that you can use with any web application, including the one that comes out of the box with DappStarter. Within DapLib, you're going to find all the contracts. So some applications might have a single contract, some applications might have multiple contracts. We then have an abstraction that we call the Dap Library. We have a proxy that allows the Dap Library to interact with the blockchain. And finally, we have unit tests. Within the client application, which is an HTML, CSS, and JavaScript application, based upon two component libraries. The first is the CSS framework called Tailwind, and then there is a web component framework called LitElement. We use LitElement primarily to make the code that goes into the web components much easier to write and without as much code and a more declarative syntax. Within the client application, you're going to find a series of pages. These are essentially pages that constitute your web application. And then you're also going to find a UI harness. Now this is something that we are really excited and proud about, because what the UI harness does is right away, within literally seconds of you having your app generated, you can start tinkering with it. You can interact with the blockchain smart contracts with a very rich user interface. You can read, you can write to the blockchain, and it's really good. We want it to be non-opinionated in our client, and so just about everything that you see that's JavaScript related is a web component, which works with pretty much every client JavaScript framework that's out there, React, Vue, Angular, etc. And finally, we have a server package in the workspace, and this uses Nest.js with a Swagger UI to help you interact with your smart contract using REST. Now, there's many blockchain applications where this may not be necessary at all, so you can completely ignore it. But there are many applications where there is an end user facing client, and then there is an administrator API, which is used internally, for example, to mint NFTs and such. Again, it's an optional thing. It's there. If you want to use it, great. If not, you don't have to use it. All right, let's go deeper into this architecture now. So at the very bottom of the stack here, we have the blockchain smart contracts. Now, DappStarter is blockchain agnostic, and this is the only point where it differs from blockchain to blockchain, where there are the contracts and there might be some additional tooling necessary to interact with the blockchain. Now, once you move up the stack, everything is JavaScript centric, and it begins with a blockchain proxy. So this is actually a file named blockchain.js, and its role is to include whatever blockchain specific libraries or SDKs or components there might be, so that everything related to that blockchain is encapsulated in this one file. So this particular file is designed to replicate a REST API, because one of the things that DappStarter wants to do is make it super simple for blockchain developers to start their journey from a Web 2 perspective. So in Web 2 with REST, you've got GET for reading, and you've got POST for submitting, and then you've got events. So we've mirrored that in DappStarter, and you've essentially got this proxy that has two methods, a GET and a POST, and then an event handler. So next up the stack comes the Dap library. As I alluded earlier, this is sort of the nerve center, and this is the point at which there is no longer any blockchain specific dependency. So Dap library is pure JavaScript, and it relies 100% on the blockchain proxy in order to interact with the actual blockchain. So if you're going to do anything that is blockchain specific, if you need to, you don't usually need to. In 99% of cases, you don't ever need to change anything in blockchain proxy. But if you do, you would want to keep your sort of blockchain specific dependencies in blockchain JS. Now, Dap library is implemented as daplib.js. Moving further up the stack. Now, in Flow in particular, we have something called an interaction transpiler. With the Flow client library, when you have a script or a transaction that needs to interact with the blockchain, you essentially have to use cadence code within an FCL JavaScript call. We wanted to separate that a little bit, and so what we've done is given you the ability to create your scripts and your transactions in cadence files, and the interaction transpiler is constantly watching those folders, and whenever you add a script or a transaction there, it immediately automatically creates the FCL wrapper for it and makes it available to the Dap library for consumption. All right, moving further up the stack, then we have all the web components that are built into DappStarter to make it super easy for you to develop dapps. So there are two primary classes of web components. There's action ones and there's widgets. Now the widgets you can think of as just UI wrappers. They're, for example, a UI wrapper to make it easy for you to select an account, etc. The actual web components that do a lot of the heavy lifting are an action card and action button. Essentially, an action card is designed to make it super simple for you to make a GET or a POST request. In other words, read or write from the blockchain, and it presents itself as a card with fields and a button. So this makes it very easy for you to add functions to your smart contract, add a function in the Dap library to interact with it, and then essentially with very minimal coding, create an action card for it so you can immediately start interacting with it. The action card is actually the UI that houses things like fields, etc. But most of the intelligent interaction with the Dap library and also getting back the results happens via the action button. Finally, as part of this architecture is Nest.js. As I alluded earlier, we've got a server package in there, and it's an optional thing if you want to use it, but it does use Nest.js, and that too interacts with the Dap library. So that's the basic architecture of DappStarter. It's very important to note that 100% of the interactivity at the JavaScript level goes through Dap library. This also includes the unit tests that are not portrayed here in this architecture stack, but the front-end UI, the unit tests, and the server API all are routed via Dap Library. So it makes it super simple for you to work with the blockchain code, because once you're done with the contracts, all you really do is work in JavaScript at the Dap Library level. So hope you found this DappStarter architecture overview useful. Thanks.